Hello friends, welcome back to another session of data structures. So today I'm going to discuss about what is a hash table. A hash table or a hash map is a data structure that implements an associative array abstract data type. Okay, so it's an array, so with some index numbers and so on, and a structure that can map keys to the values. So here the keys could be employee ID and the values could be employee name, or it could be the customer ID and then the value could be the customer name or so on. So a hash table uses hash function to compute an index also, which is also called as a hash value. So you can see here uh, the hash function actually is mapping the keys. Okay, so this is the key which is actually mapped to the zero index. So this is an array. So we already know that an array is an indexed data structure. So the array indexes starts from 0 to n minus 1 if n is the size of the array. So key one is mapping. So this hash function over here will decide like where it should be going in the array. So say for example, key one is when computed in the hash function, like it is generating an index number of 0. So the value associated with the key one will go into 0th index. Okay, so this is where it is going. And then coming to key 2, again it's going into the hash function. So then say it is mapped to index number 1, so the value goes over here. So this is actually the process of putting the key values in the hash table. So what's a hash function? A hash function is any function that can be used to map data of arbitrary size, okay, to fixed size value. So this is very important to understand. So variable length keys, whatever we have, like the keys could vary from minus infinite to plus infinite. So, but we don't have minus infinite to plus infinite indexes in an array, right? So indexes in an array are limited. So we just need to map these arbitrary sizes of keys into these particular indexes. So say for example, the array size is 5. Okay, so what indexes do we have? So I'll be having indexes starting from 0, 1, 2, 3, and 4, right? So these are only the indexes that are available. So whatever may be the value, say for example, because 5 is the size of the array, so we need to compute the hash function in such a way that whatever value that this hash function will give you, so it should be within this particular range, like 0, 1, 2, 3, and 4. So say for example, I have a key of 55. So 55 mod 5 will give me a 0. So I'll be putting the value at 0th location. So whatever is the value, so the value should be mapped only within these particular indexes that are available. So this is what is called as a hash function. So the values written by a hash function, we call them as hash values, or we call them as hash codes, or we also call them as digests, or simply we say that there are hashes. Okay, fine. So we'll see what are the ideal hash function characteristics. So the first characteristic is the deterministic characteristic. So whatever input that we are giving, so it should always generate the same hash value. And the benefit of this is that like the storing of the data and retrieval of the data from the hash table becomes very easy because it's giving the same value, right? So next point characteristic is the uniform distribution. So it distributes hash values evenly across the output range, so that there are no clustering forms. Say for example, if it's not distributing the hash values uniformly across the table, so there is a tendency that all the values get accumulated at a particular position. Okay, so say for example, I have a hash table of size from which is 50 size, and the hash indexes are from 0 to 49. So the hash function should not accumulate the values at particular location, like all the values are getting accumulated in between from 0 to 9. So this is called as clustering. So it should not do that. Okay, so what the values, the hash values that we get should be distributed across, like from 0 to 49 it should be able to distribute among all these values. So such kind of hash function we need to pick. And also the efficiency, like the hash function should not be very complicated in the formula, like the algorithm should not be very complicated, like so many calculations should not be there. So the hash function should be very simple, and also it should be it should give the result in a faster way, like the fast computation should happen even for the large inputs. So even if the inputs are very large, it should be able to compute the hash values very fast, suitable for the performance of the critical applications, and also minimizing collision. So the hash function should not map to the same hash value most of the time. Okay, so we cannot avoid collisions. Avoiding collisions is like is not possible. Is not possible. But whatever hash function we are choosing, it should be able to minimize collisions. Okay, so the number of collisions that occur whenever we are mapping the keys onto the hash table, the number of collisions should be minimized. Yeah, the last characteristic is the pre-image resistance. So this is for the cryptographic hashes. Okay, so it should be infeasible to reverse engineer the input from the hash value. So the somebody, a hacker or somebody, should not be able to reverse engineer the hash value and get the input. Okay, so that should not be possible. So the hash function should do that. And for example, we should be able to give security in password storage and digital signatures and data integrity and so on. So next we'll see what are the various types of hash functions. So these are the various types of hash functions available. So you can choose any one of them based on your requirement. So the first one is the division method, second one is mid square, and the third one is folding, and the fourth one is the multiplication method. So we'll try to discuss the differences between all these four in detail right now. So the first one is modulo division method. So which uses the modulus operation to map values to a smaller range. Okay, so this is used for mapping, as I said, like the minus infinity to plus infinity size of input, like it will be able to map into a smaller range of indexes that are available in the array. And the characteristic is like it's very simple because it just uses modulus operation, and then it is very fast. And the efficiency of this method depends on the choice of m. As you can see, like here we have the hash function given. So the hash value is equal to key mod table size. So the table size is considered to be m over here. So the m is nothing but the table size. So the efficiency depends on what is the table size that we are choosing. And generally we'll be choosing the table size, which is nothing but a prime number. So the use cases are, so it is used in basic hash tables, and for simple applications which require speed, then we'll be using the modulus division. And the next one is multiplication method. So the multiplication method multiplies the key by a constant. Is a constant which is chosen like this. So a is equal to square root of 5 minus 1 by 2. This is the most popular way, like we choose a. So a is generally equal to 0.618. Okay. So what we do in multiplication method is like the hash value is calculated as floor of table size into key into a mod 1. Okay, right, from distribution of the hash values. So this is one advantage that we get, and it is less sensitive to m. Okay, so the table size, it's not completely depending on the table size. We also have a over here, which again helps us in distributing the keys evenly across the table. So the purpose of choosing A is to distribute the keys uniformly across the table. So the hash tables with the non-uniform keys, so it's suitable for such kind of tables, and also it's a in randomized algorithms we can use multiplication method. So the next method is the mid square method. So squares the key and extracts middle digits for the hash value. So as the uh, description of the method itself is saying that square the key. Okay, so this is suitable for the keys like which are very large. So we'll be choosing the mid square method if the key is very large, like the number of digits in the key is very large. We'll be choosing the mid square method. So squares the keys and extracts the middle digits for the hash value, and can produce good distribution if keys are uniformly distributed. And then more complex and computationally expensive because we just need to do the square, and it's a two-step process. So we'll be squaring it and then extracting the middle digit. So it's a little bit more computations are involved in calculating the hash values, and it's suitable for where keys have some inherent order or some pattern. So we'll be choosing the mid square method. So as I said, like it's a two-step process. So we'll square the key k and extract the middle digits. Not only this, the multiplication method is also a two-step process. And the next one is the folding method. So the folding method is like breaks the key into equal size parts, combines these parts to produce hash value. So this is again suitable for larger keys, like the keys with more number of digits will be using the folding method. And then it's a flexibility in handling various key types, and distribution depends on how parts are combined. Okay, right. And the use cases are like the hash tables with large numerical keys and situations requiring adaptability. So as I said again, we'll divide the key into equal parts and sum the parts and apply modulus if necessary to fit the table size. So this is the procedure of the folding method. To summarize all these four methods, so as I said, like the division method is simple, fast, and best for general users. And mid square method produces good distribution suitable for ordered keys. And then folding method is simple and flexible and good for large numeric keys. And then multiplication method produces uniform distribution. So in for general purpose hash functions, particularly for hash tables, the multiplication method is typically preferred due to its good balance of performance and uniform distribution. However, the modulus method is still widely used for the simplicity and efficiency, especially when the key distribution is well understood and the table size, which is M, is chosen carefully. The mid square method and folding methods are less commonly used due to its complexity and sensitivity to input data characteristics. So this is the summary of all this. So we understood that modulo and the multiplication methods are the most popular methods. So say for example, I have a key which is 50, and then I just wanted to map it to the I just wanted to map it to the table and say the hash function is k mod 11. So I'll be saying 50 mod 11, so which will give me 6. So where does 50 go in the hash table? So in the hash table, okay, so say for example, this is my hash table. Okay, so which is from 0 to 11, which is like 10. So these are all the available locations. So 1, 2, 3, 4, and so on. So 5, 6, and so on. Okay, so where does this 50 go? This 50 will go at the sixth location. So this is 50. So I'll be mapping this onto the hash table like this. Okay, fine. So say for example, I have a key which is a alphanumerical data. So Apple, say for example, I have Apple, which is alphanumerical data. So in that case, how do you map it onto the table? We'll just look at that. So the first thing that I generally do is, so we just need to convert each and every character into its ASCII value. So A is 97 in the ASCII table, and P 112 and P 112 and 108 and 101. It is like all the letters given here are in lowercase. So it also depends on what whether you're giving uppercase and so on. Okay, right. So first thing is we just converted the characters into the ASCII value, summing up all these values. So when you sum up all these values, I got 530. Okay, right. So this 530, I'll be doing, this is the numerical, we converted the alpha numerical to the numerical type now. So 530 mod 11. Okay, so 530 mod 11 has given me a hash value of 2. So this will go to the second index in the array. Okay. So hashing is the practice of using an algorithm which is like hash function. Hash function is a algorithm that we choose to map data of any size to fixed length. So this is very important. So as I already said in the beginning, like arbitrary size of data to the fixed length. So this is what is the responsibility of the hashing. Okay, so all this process of picking up a hash function and then taking the keys and giving it to the hash function and then generating the hash value and so on, all this entire process is called as hashing. And we also can call hashing as scatter storage address. So hashing is also called as scatter storage address. So we'll be a scatter is where like we'll be distributing it across uniformly across all the indexes of the hash table of the array. So that's what is called as scattered and storage addressing. Okay, so how we are storing the values onto the array or the hash table is the essence over here. So hashing is the practice of using an algorithm or hash function to map data of any size to fixed length. So in my upcoming video, I'll discuss collision and I'll talk about various collision resolution techniques. I hope this video is helpful to you. Thank you for watching.